The Border Gateway Protocol, or BGP, is the routing protocol that powers the Internet. It is essential for enabling communication between different networks around the world. The Border Gateway Protocol is the routing protocol of the Internet. It is an exterior gateway protocol that enables the Internet to exchange routing information between autonomous systems. The current version is BGP version 4, as specified in RFC 4271. It uses TCP port 179 for reliable communication. BGP is a path vector protocol that makes routing decisions based on paths, network policies, or rule sets. An autonomous system, or AS, is a collection of connected IP networks under the control of a single organization that presents a common routing policy to the Internet. Each autonomous system is assigned a unique ASN, or Autonomous System Number. These numbers range from 1 to 4,294,967,295. Private Autonomous System Number ranges are from 64,512 to 65,534, and from 4,200,000,000 to 4,294,967,294. Autonomous system numbers are allocated by the Internet Assigned Numbers Authority, or IANA, to regional Internet registries, or RIRs. There are two main types of Border Gateway Protocol, or BGP, external BGP and internal BGP. External BGP sessions occur between routers in different autonomous systems and connect different organizations or networks. It typically runs between edge or border routers and has a default time to live, or TTL, value of 1, meaning it is only for adjacent routers. It modifies the autonomous system path attribute when advertising routes and is the primary method for Internet routing exchange. Internal BGP sessions occur between routers within the same autonomous system. It distributes external routes throughout an autonomous system. It requires full mesh peering or route reflectors. It does not modify the autonomous system path attribute. It uses an underlying interior gateway protocol, such as Open Shortest Path First, Enhanced Interior Gateway Routing Protocol, or Intermediate System to Intermediate System, for reachability, and maintains BGP attributes across the autonomous system. BGP uses four primary types of messages for communication and maintaining sessions. The first is an open message, which is the first message sent after a TCP connection is established. It includes the BGP version, autonomous system number, and hold time, and contains the BGP identifier, also known as the router ID, and carries optional parameters, such as capabilities. This message initiates the BGP session establishment. The second type of message is the update message, which is used to advertise or withdraw routes. It contains withdrawn routes, path attributes, and network layer reachability information. It carries BGP attributes, such as the autonomous system path and next hop, and is the core message for route exchange, advertising multiple prefixes with the same attributes. The third type of message is the keep alive message, which are periodic messages sent to maintain a BGP session. They are sent periodically, typically every 60 seconds, and contains only the message header with no data. It prevents the hold timer from expiring, confirming that the BGP session is still active. The final type of message is the notification message, used for error reporting and session termination. It indicates error conditions and contains an error code and subcode, usually resulting in BGP session termination and providing diagnostic information. Key BGP path attributes are used to determine the best path for routing traffic. The first is the autonomous system path, which is a sequence of autonomous system numbers that a route has traversed. It is used for loop prevention and path selection. The next hop is the IP address of the next router to reach the destination network, critical for packet forwarding. Local preference indicates the preference for a route within an autonomous system. Higher values are preferred, and it is only used in internal BGP. Origin indicates how BGP learned about a route, either through an interior gateway protocol, exterior gateway protocol, or is incomplete. The multi-exit discriminator, or MED, suggests a preferred entry point to an autonomous system, with lower values preferred, but is not compared between different autonomous systems. Community is an optional attribute used to group routes for applying common policies, formatted as autonomous system number, then value. Atomic aggregate indicates that a specific route has been aggregated, and some path information might be missing. Weight is a Cisco proprietary attribute, where higher values are preferred, and is only used locally on the router. The BGP path selection process is an algorithm that determines the best path to reach a destination network. The first step is the highest weight, a Cisco proprietary attribute. Next is the highest local preference. Then locally originated routes. Then the shortest autonomous system path length. Next, the lowest origin type, where interior gateway protocol is less than exterior gateway protocol, which is less than incomplete. Then the lowest multi-exit discriminator. Next, external BGP over internal BGP paths. Then the lowest interior gateway protocol metric to the next hop. Next, the oldest path or the most stable, and finally the lowest router ID. A problem that can occur with internal BGP is the full mesh requirement, where in a standard internal BGP deployment, every BGP router must peer with every other BGP router in the autonomous system, which does not scale well. Route reflectors are a solution that allow a router to reflect or redistribute internal BGP learned routes to other internal BGP peers, reducing the number of required peering sessions. This eliminates the need for a full internal BGP mesh, significantly reducing the number of BGP sessions, where clients only need to peer with route reflectors. Multiple route reflectors can be deployed for redundancy, and a hierarchical design is possible with route reflector clusters. Full mesh sessions are calculated as n times n-1 divided by 2, so for 10 routers there would be 45 sessions. With route reflectors, it is calculated as n-1, so for 10 routers there would be 9 sessions. BGP communities are optional attributes that group routes to apply common routing policies. They provide a flexible way to influence route selection and distribution. There are 3 types of communities. Standard communities are 32-bit values represented as ASN then value, for example 65,000:100. Extended communities are 64-bit values with more flexible structure for advanced use cases. Large communities are 96-bit values in the format ASN:function:parameter, for example 65,000:1:200. Some well-known communities are no export, do not advertise to external BGP peers, no advertise, do not advertise to any peer, local as, do not advertise beyond the local AS, and internet, advertise to the internet community. Some operational best practices are to implement proper filtering with inbound and outbound prefix filters to prevent route leaks and unauthorized announcements. Use route dampening to suppress frequently flapping routes and improve network stability. Establish multiple BGP connections to different providers for redundancy and improved fault tolerance. Configure appropriate BGP timers to balance between fast convergence and stability. For security considerations, use Message Digest 5, or MD5, authentication for BGP sessions to prevent unauthorized peers and session hijacking. Implement Resource Public Key Infrastructure, or RPKI, and Route Origin Authorization, or ROA, to validate route origins. Implement BGP Time to Live Security Hack, or BTSH, to protect against remote attacks by requiring packets to have specific time to live values. Configure maximum prefix limits to prevent route table exhaustion attacks and protect against route leaks. BGP is the foundation of Internet routing, but requires careful implementation and security considerations to maintain a stable and secure network infrastructure. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.